There are cities on this earth where surviving a single season means enduring atmospheric forces powerful enough to flatten entire neighborhoods, submerge coastlines beneath walls of water, and erase decades of infrastructure in a matter of hours. Places where the question is never whether a catastrophic storm will arrive, but when. Where residents wake up each morning knowing that the sky above them has already killed thousands of people who once stood in the same streets, slept in the same homes, and believed they were safe. Some of these cities have been rebuilt from near complete destruction, not once, not twice, but more times than their own historians can count. Others exist in atmospheric corridors so violent that professional meteorologists, people who have spent careers flying directly into the eyes of hurricanes, openly admit they would hesitate before choosing to live there. And the location waiting at number 1 on this countdown exists in a state of perpetual atmospheric siege, so extreme that scientists are still working to understand how any permanent civilization could survive there at all. These are not forgotten places. These are not remote outposts on the edges of maps. These are real cities with real populations, real economies, and real communities who have made the extraordinary decision to remain in some of the most meteorologically violent places on the surface of the planet. This is our countdown of the top 10 storm-battered cities even meteorologists are afraid to inhabit. Stay until the end, because number 1 experiences a level of atmospheric violence unlike almost anywhere else on Earth. Number 10, Galveston, Texas, United States. Sitting on a narrow barrier island at the northwestern edge of the Gulf of Mexico, Galveston, Texas, occupies one of the most geographically vulnerable positions of any major American city, with a current population of approximately 53,000 people. This compact island community sits at an average elevation of just under 8 feet above sea level, a statistic that, given its location in one of the most active hurricane corridors on the planet, reads less like a geographic footnote and more like a warning. Before the 20th century had even fully begun, Galveston had already experienced what remains the deadliest natural disaster in United States history. On September 8, 1900, a Category 4 hurricane made landfall directly over the island, with sustained winds exceeding 145 miles per hour and a storm surge estimated at 15 feet. In a single night, between 6,000 and 12,000 people lost their lives. The range in that death toll is not imprecision. It reflects the fact that so many of the dead were simply swept into the Gulf and never recovered. Entire neighborhoods ceased to exist. The storm destroyed more than 3,600 buildings. 1/3 of the island's population perished before dawn. What happened next is, by any measure, one of the most remarkable acts of collective defiance in American engineering history. Rather than abandon the island, Galveston raised itself. Residents and engineers dredged an enormous volume of sand and fill material to physically elevate the ground level of the entire city by as much as 17 feet in some areas. A 17-foot-tall granite seawall was constructed along the Gulf-facing shoreline, a structure that still stands today, extending for more than 10 miles and representing one of the most ambitious coastal engineering projects ever undertaken in North America. The seawall has not made Galveston immune. In 2008, Hurricane Ike, a massive Category 2 storm with a storm surge that behaved more like a Category 4 event, drove walls of water over the island's unprotected bayside, causing approximately $30 billion in damage and killing dozens of people. The storm wiped out the communities of Bolivar Peninsula across the channel, a region that had felt protected by proximity to Galveston's legendary defenses. Meteorologists point to Galveston as a case study in the limits of human engineering against natural forces. The seawall protects the protected. The rest of the island remains exposed. And every hurricane season, forecasters watch Gulf water temperatures with a specific kind of dread that is reserved for systems approaching this particular strip of Texas coastline. The waters of the Gulf of Mexico are warming, storm surges are growing, and Galveston's geography has not changed. But the city ahead on this list doesn't just face hurricanes. It faces something that comes with almost no warning at all. Number 9, Moore, Oklahoma, United States. There are cities that sit in the path of storms, and then there is Moore, Oklahoma, a suburban community of approximately 62,000 people located just south of Oklahoma City, which appears to exist at the precise intersection of every atmospheric condition required to produce the most violent tornadoes on Earth. Moore is located in the heart of what climatologists and meteorologists have long called Tornado Alley, the corridor of central North American geography, where cold, dry air from Canada collides with warm, moist air flowing northward from the Gulf of Mexico, producing supercell thunderstorms of extraordinary rotational power. But even within Tornado Alley, Moore occupies a position of almost statistical impossibility. The same city has been struck by catastrophic tornadoes with a frequency that defies conventional probability. In May 1999, a tornado rated F5, the maximum possible rating on the Fujita scale at the time, tore through Moore with winds measured at 301 miles per hour, the highest surface wind speed ever recorded on Earth at that point. The storm destroyed more than 8,000 homes and businesses, killed 36 people, and carved a path of total destruction nearly 40 miles long and more than a mile wide through the community. The economic damage exceeded $1 billion. Entire subdivisions were reduced to bare concrete foundations. 11 years later, in May 2010, another violent tornado struck Moore. Then, in May 2013, the city was devastated again. The 2013 tornado reached EF5 intensity, the equivalent rating under the updated enhanced Fujita scale, with winds exceeding 210 miles per hour. It was on the ground for 39 minutes, and cut a path of destruction 1.3 miles wide through the city center. It struck 2 elementary schools while children were still inside. 24 people died, including 7 children. Economic damage totaled approximately $2 billion. Meteorologists who study Moore have noted something deeply unsettling about the city's repeated destruction. The storms are not random. The same atmospheric corridor, fed by the same convergence of air masses, tends to produce tornado tracks that follow similar geographic paths through this specific region. Moore does not simply live in Tornado Alley. It lives near the center of one of the most statistically active tornado corridors ever documented. The city has rebuilt each time, incorporating storm shelters into building codes and redesigning schools with reinforced safe rooms. Residents speak about their relationship with the sky in terms that outsiders find difficult to comprehend. A permanent awareness, a seasonal vigilance, a learned acceptance of a threat that can go from zero to unsurvivable in under 10 minutes. But tornadoes, for all their violence, are measured in minutes. The city coming up next endures storms that last for days, and the damage they leave behind takes decades to recover from. Number 8. Dhaka, Bangladesh. Bangladesh is a nation defined by water, formed almost entirely by the vast delta system of the Ganges, Brahmaputra, and Meghna rivers. It is one of the most low-lying, flood-prone countries on Earth. And at the center of this geography sits Dhaka, the nation's capital and one of the most densely populated cities in the world, home to approximately 22 million people packed into an urban area of roughly 300 square kilometers. The atmospheric threat to Dhaka does not come solely from above. It comes from every direction simultaneously. The Bay of Bengal, which forms Bangladesh's southern coastline, is one of the most cyclone-active bodies of water on the planet. Warm water temperatures, shallow coastal geometry, and the funnel shape of the bay combine to amplify cyclones as they approach landfall, driving catastrophic storm surges inland across a landscape that offers almost no natural elevation as defense. The history of cyclonic destruction in Bangladesh is almost incomprehensible in scale. In November 1970, the Bhola cyclone made landfall over what was then East Pakistan, with a storm surge estimated at 20 to 30 feet. Between 300,000 and 500,000 people died, the deadliest tropical cyclone ever recorded in human history. In 1991, Cyclone 02B struck with winds exceeding 155 miles per hour and a storm surge that pushed 20 feet of seawater miles inland. An estimated 138,000 people died, and 10 million were left homeless. Dhaka itself, sitting further inland along the Buriganga River, faces a different dimension of the threat: catastrophic urban flooding driven by monsoon rains, compounded by storm systems in the bay. The city's drainage infrastructure, designed for a fraction of its current population, is incapable of handling the volumes of water that modern climate patterns now deliver. In recent years, flooding events that were once described as once-in-a-generation occurrences have begun arriving multiple times per decade. Meteorologists and climate scientists studying the Bay of Bengal have raised specific alarms about the trajectory of cyclonic intensity in this region. Warming ocean temperatures are producing stronger storms. Sea level rise is increasing baseline flood risk across the delta, and Dhaka's population continues to grow, driven by a cycle in which climate displacement in rural and coastal areas pushes survivors toward the city, which faces its own escalating climate threat. The resilience of Dhaka's population is extraordinary, but the atmospheric forces bearing down on this city are not diminishing. They are intensifying. What comes next, though, is a city that doesn't wait for storm season. For this location, there is no safe time of year. Number 7. Norilsk, Russia. Most entries on a list of the world's most storm-battered cities involve heat, humidity, and the violent tropical energy of hurricanes and cyclones. Norilsk, Russia, operates according to entirely different meteorological rules, and those rules are, in their own way, more relentlessly punishing than anything the tropics produce. Located 300 kilometers north of the Arctic Circle in northern Siberia, Norilsk is home to approximately 180,000 people, making it one of the largest cities in the world, built above the Arctic Circle, and the northernmost city on Earth, with a population exceeding 100,000. It exists in a landscape of permafrost, tundra, and near total darkness for months at a time, and it is battered not by warm season storms, but by a continuous, months-long assault of polar weather that would qualify as extreme emergency conditions anywhere else on Earth. Winter in Norilsk lasts approximately 8 to 9 months. Average January temperatures fall to minus 30 degrees Celsius, with recorded extremes approaching minus 56 degrees Celsius. But temperature alone does not capture the full picture of Norilsk's meteorological violence. The city sits in a corridor that channels Arctic winds across the open tundra, with almost no geographic barrier to interrupt them. Blizzards in Norilsk are not measured in hours. They are measured in days, sometimes weeks, and they arrive with winds exceeding 100 kilometers per hour, carrying walls of ice particles that make outdoor visibility effectively zero. The city experiences a phenomenon known locally as purga, a specific type of ground blizzard, in which existing snow is lifted and driven horizontally by extreme wind, creating whiteout conditions even during periods with no active snowfall. During purga events, residents do not go outside. Connecting rope lines between buildings have historically been used so that people attempting to travel short distances in emergency conditions could find their way without becoming disoriented and freezing to death within meters of their destination. The reasons people live in Norilsk are largely economic. The city sits above one of the world's richest deposits of nickel, copper, palladium, and platinum. The Norilsk nickel mining and metallurgical complex is one of the largest industrial operations of its kind on the planet, and the wages it offers attract workers willing to endure conditions that most of the world's population would consider uninhabitable. Meteorologists studying polar climate systems point to Norilsk as evidence that storm damage is not always measured in wind speed and storm surge. Sometimes it is measured in the slow, grinding attrition of a climate that simply never relents. And yet, everything seen so far on this list is, in some sense, predictable. The city arriving at number 6 creates a different kind of fear, because its storms develop with almost no time to prepare. Number 6. Darwin, Australia. In the early hours of December 25th, 1974, most of Darwin, Australia, was asleep. The city of approximately 47,000 people at the time had been watching Tropical Cyclone Tracy for several days, but forecasters had consistently underestimated its intensity and its precise track. By the time meteorologists understood what was about to happen, it was too late for most residents to evacuate. Cyclone Tracy made landfall directly over Darwin at approximately midnight on Christmas morning, with winds of 217 kilometers per hour and possibly higher, as the anemometer measuring wind speed was destroyed before it could record the peak. The storm was extraordinarily compact, measuring only 48 kilometers across, which concentrated its energy with devastating efficiency. It crossed directly over the city center. By dawn on Christmas Day, 71 people were dead. More than 70% of Darwin's buildings had been either destroyed or rendered uninhabitable, and approximately 35,000 people, nearly the entire population, had to be evacuated from the city in what remains the largest peacetime evacuation in Australian history. The destruction was so complete that serious consideration was given to simply abandoning Darwin and not rebuilding. The city's entire infrastructure, power, water, communications, transportation, had been obliterated. What existed before December 24th was, in most practical senses, gone. Darwin was rebuilt. It grew. Today, it is home to approximately 150,000 people and serves as the capital and primary economic hub of Australia's Northern Territory. Its reconstruction incorporated new cyclone-resistant building standards that became a model for tropical construction across the region, and its meteorological services were transformed in the aftermath of Tracy into some of the most sophisticated cyclone monitoring operations in the southern hemisphere. But the atmospheric threat to Darwin has not diminished. The city sits at the top of Australia, in a region that experiences one of the world's most active tropical cyclone seasons. Warming ocean temperatures in the Timor Sea and Arafura Sea are producing systems of increasing intensity. And Darwin's geography, a coastal city on a low-lying peninsula surrounded on three sides by open water, remains as exposed today as it was the night Tracy arrived. Meteorologists who study the Australian cyclone basin describe Darwin as a city living on borrowed time between major events. The question is not whether another Tracy-level storm will come. The question is what the city will look like when it does. If you're finding these incredible places fascinating, make sure to subscribe and turn on notifications, because the locations still ahead become even more extreme. Number 5. New Orleans, Louisiana, United States. There is a version of New Orleans that exists in popular imagination, a city of music, cuisine, cultural richness, and a certain defiant joy that seems almost supernatural given everything the city has endured. That version is real, but it exists alongside another reality, one that meteorologists and hydrologists have understood for decades, and that the rest of the world was forced to confront on August 29, 2005. New Orleans is home to approximately 390,000 people and sits in one of the most hydrologically precarious positions of any major city in the world. The city is located between the Mississippi River and Lake Pontchartrain, and much of it sits below sea level, in some areas more than 6 feet below. It is surrounded by a complex system of levees, flood walls, and drainage pumps that represent one of the most elaborate flood control engineering systems ever constructed, and it sits directly in the path of Gulf of Mexico hurricanes that travel northward along a track that has made landfall near New Orleans with devastating regularity throughout recorded history. Hurricane Katrina made landfall as a Category 3 storm east of New Orleans on the morning of August 29, 2005. The storm surge it generated, in some areas exceeding 25 feet, overwhelmed and then destroyed multiple sections of the city's levee system in more than 50 locations. Within hours, approximately 80% of the city was underwater. The flooding reached depths of 15 feet or more in some neighborhoods. More than 1,800 people died. Approximately 400,000 residents were displaced. Economic damages totaled more than $125 billion, making Katrina the costliest natural disaster in United States history at the time. What Katrina exposed was not simply the power of the storm. It exposed decades of deferred maintenance, systemic underinvestment in flood infrastructure, and the fundamental reality that New Orleans' existence depends entirely on engineered systems that can fail. The city did not flood primarily because of wind or rain. It flooded because the walls designed to keep the water out collapsed. Since Katrina, more than $14.5 billion have been invested in rebuilding and upgrading the city's flood protection systems. The new levees and flood walls are stronger, higher, and more sophisticated than anything that existed in 2005. But hydrologists note that the city's land continues to subside, sinking by as much as an inch per year in some areas due to the compaction of deltaic sediments and the withdrawal of groundwater. The ground is getting lower, the sea is getting higher, the storms are getting stronger. Meteorologists describe New Orleans not as a city that has solved its relationship with water, but as a city that has bought itself time. Every hurricane season, the same calculation is made: how strong, how close, how fast, and in which direction. The city next on this list didn't build walls to hold the water out. The water there comes from a direction that walls cannot stop. Number 4. Tacloban, Philippines. On November 8, 2013, one of the most powerful tropical cyclones ever recorded in history made landfall over the eastern Visayas region of the Philippines. Super Typhoon Haiyan, known in the Philippines as Yolanda, arrived with sustained winds of 315 kilometers per hour and gusts estimated at 380 kilometers per hour. But it was not the wind that killed the most people, it was the water. Haiyan generated a storm surge, a wall of ocean water pushed inland by the storm's rotation and forward momentum that reached heights of 6 meters or more in some coastal areas. In the city of Tacloban, located on the northeastern coast of Leyte Island, with a population of approximately 220,000 people, the surge arrived with the force and speed of a tsunami. Entire neighborhoods were swept away within minutes. The storm hit at low tide, Had it arrived at high tide, the surge would have been even higher. More than 6,300 people died in the Philippines as a result of Haiyan, with Tacloban suffering the highest concentration of casualties. Tens of thousands more were injured. More than 4 million people were displaced. The total economic damage across the Philippines exceeded $2.2 billion, but the human cost was incalculable. Entire family lines eliminated. Communities where every house on every street was destroyed. A city left without power, water, food, or functional government for weeks after the storm. The Philippines sits astride the most active typhoon corridor on Earth. The country experiences an average of 20 tropical cyclones per year, more than any other nation. It is located in the western Pacific warm pool, where ocean surface temperatures provide virtually unlimited energy to developing storm systems. And because of the archipelago's geography, thousands of islands oriented perpendicular to the prevailing storm tracks, typhoons make landfall in the Philippines with a frequency and intensity that meteorologists elsewhere in the world find almost incomprehensible. Tacloban has rebuilt. Survivors returned. The city grew again. Meteorologists who visited the area after Haiyan described the reconstruction as an act of both practical necessity and profound cultural identity. Tacloban exists in this place because this is home, and the concept of home carries a weight that transcends meteorological risk calculation. But researchers studying typhoon intensification in the Western Pacific have documented a troubling trend. The strongest storms, those reaching super typhoon status, are becoming more common. Rapid intensification events, in which storms strengthen dramatically in short periods, are occurring more frequently. The Western Pacific is warming, and Tacloban sits in the direct path of whatever that warming produces. What comes next on this list is a place where the storms are so constant, so embedded in daily life, that the city has essentially built its entire culture around the fact that destruction is never more than one season away. Number 3. Miami, Florida, United States. Miami occupies a position that urban planners, climate scientists, and insurance actuaries have increasingly described in language that would have been considered alarmist a generation ago. This city of approximately 470,000 people, part of a broader metropolitan area of nearly 6 million, sits on a thin limestone peninsula between the Atlantic Ocean and Biscayne Bay at an average elevation of approximately 6 feet above sea level, in the direct path of Atlantic hurricane tracks, and above a porous bedrock that cannot be protected from rising seas by any wall or levee system ever conceived. Miami has been struck by catastrophic hurricanes throughout its history. The Great Miami Hurricane of 1926 arrived when the city was in the middle of a real estate boom and nearly ended it entirely, killing 373 people and causing damages that in today's dollars would exceed $180 billion. The Labor Day hurricane of 1935, the most intense Atlantic hurricane ever to make landfall in the United States, crossed the Florida Keys just south of Miami with a central pressure of 892 millibars and winds exceeding 185 miles per hour. In 1992, Hurricane Andrew made landfall just south of Miami as a Category 5 storm, destroying over 125,000 homes, leaving 175,000 people homeless, and causing $27 billion in damage. But what distinguishes Miami from every other major American city facing hurricane risk is a problem that exists entirely separately from storms. The city is already flooding, and it is flooding on sunny days. Miami sits atop the Biscayne Aquifer, a porous limestone formation that groundwater and seawater move through freely. As sea levels rise, that water pushes upward through the rock and emerges in streets, parking lots, and building foundations, regardless of weather conditions. Miami neighborhoods now experience what is called sunny day flooding, street-level inundation during high tides with no storm present. This phenomenon has increased dramatically in frequency over the past 2 decades, and projections suggest it will become a daily occurrence in low-lying areas within decades. Meteorologists and climate scientists have identified Miami as among the most climate-vulnerable major cities in the world. Not merely because of what storms might bring, but because of what is already happening. When the next major hurricane makes landfall over this city, and forecasters regard it as a matter of certainty, not possibility, it will strike a city whose baseline flood risk has already been transformed by a rising sea. The economic consequences of a direct Cat 4 or Cat 5 strike on Greater Miami have been modeled at figures approaching $300 billion. The human consequences are harder to model because the city's population density its infrastructure, and its geography combined to create evacuation challenges that keep emergency management officials awake at night. Miami has not yet had its defining catastrophic moment with a modern direct hurricane strike. Meteorologists know that moment is coming. What is coming next on this countdown, though, is a city that has already had that moment many times over, and where the science of what is happening in the atmosphere above it remains, in some respects, deeply frightening, even to those who study it professionally. Number 2. Chittagong, Bangladesh. Bangladesh appears twice on this list because the scale of its meteorological vulnerability defies containment within a single entry. While Dhaka faces the amplified urban flooding and infrastructure crisis of a megacity, Chittagong, the nation's second-largest city and primary seaport, with a population of approximately 5 million people, faces something more direct, more violent, and more repeatedly catastrophic. It sits on the Bay of Bengal coastline at the precise geographical location where the bay's cyclone-amplifying geometry delivers maximum energy directly onshore. Chittagong's position at the northeastern corner of the Bay of Bengal is, from an atmospheric science perspective, almost perfectly situated for catastrophic cyclone impacts. The bay's funnel shape means that storm surges have nowhere to dissipate as they approach the coast. They compress and they rise. The shallow coastal waters amplify wave heights and surge velocities, and the land immediately behind the coast is flat, deltaic, and barely elevated above the tide line. When a major cyclone arrives at Chittagong, the surge doesn't merely flood the coast, it travels miles inland across a landscape that provides no resistance. In 1991, Cyclone 02B, one of the deadliest tropical cyclones of the 20th century, made landfall near Chittagong with a 20-foot storm surge and 160 miles per hour winds. The death toll in the region surrounding the city exceeded 138,000 people. Entire coastal communities were erased. In 2007, Cyclone Cedar struck the Bangladeshi coast further west, but still produced lethal impacts across Chittagong's hinterland. In 2009, Cyclone Ayla damaged coastal areas and triggered flooding that contaminated freshwater sources for hundreds of thousands of people. In 2020, Cyclone Amphan, one of the most powerful Bay of Bengal cyclones ever recorded, required the evacuation of millions of people from coastal areas around Chittagong. What meteorologists find most alarming about Chittagong is not the history of what has already occurred, but the trajectory of what is coming. The Bay of Bengal has warmed approximately 1 degree Celsius over the past century. An analysis of storm records indicates that this warming is producing a measurable increase in rapid intensification events, storms that go from moderate tropical cyclones to major Category 4 or 5 equivalents in timeframes of 24 hours or less, giving populations almost no opportunity to respond. Chittagong is also one of the world's most important shipping hubs, home to Bangladesh's primary container port. A catastrophic cyclone strike does not merely kill and displace people. It disrupts global supply chains, destroys industrial infrastructure, contaminates water supplies, and creates public health crises that persist for months. The city's role in the global economy means that what happens in Chittagong during a major storm reverberates far beyond Bangladesh's borders. Scientists studying the Bay of Bengal describe the combination of factors converging on Chittagong: warming seas, rising baseline sea levels, increasing storm intensity, extreme population density, and limited evacuation infrastructure as a compound risk scenario without precedent in recorded history. But even Chittagong, with all of its documented history and all of the scientific alarm it has generated, does not occupy the #1 position on this countdown. The city at #1 does not simply face powerful storms. It faces an atmospheric reality so extreme, so continuous, and so scientifically significant that the location has become, for meteorologists worldwide, a reference point for the outer edge of what permanent human habitation can endure. Number 1, Bhubaneswar and the Odisha coast, India. There are places on Earth where meteorologists use superlatives that feel inadequate. The Odisha coast of eastern India and the state capital, Bhubaneswar, which serves as the governmental and logistical hub for a coastal region home to more than 45 million people, occupies a position in the history of catastrophic weather that has no parallel in the modern world. Odisha is the most cyclone-prone state in India. It sits on the northwestern corner of the Bay of Bengal, precisely where the bay's cyclone-generating and cyclone-amplifying dynamics are most powerful. The state has been struck by major cyclones more frequently than any comparable coastal region on Earth, with documented catastrophic events occurring in 1971, 1982, 1985, 1988, 1989, 1990, 1995, 1996, 1997, 1999, 2007, 2008, 2010, 2013, 2014, 2018, 2019, 2020, 2021, and 2023. In some years, multiple major systems have affected the coast within the same season. But it is the super cyclone of October 1999 that defines Odisha's relationship with atmospheric violence in terms that meteorologists still cite when they want to describe the outer boundary of what tropical cyclone intensity can produce at landfall. The 1999 Odisha super cyclone made landfall near the town of Paradip, less than 100 kilometers from Bhubaneswar, with a central pressure of 912 millibars, making it the most intense landfalling cyclone ever recorded in the Bay of Bengal at that time. Sustained winds exceeded 260 kilometers per hour. The storm surge reached 35 feet in some coastal areas. More than 15,000 people died. Official figures that most researchers believe significantly undercount actual mortality, given the destruction of entire coastal villages where no survivors remained to report. Approximately 15 million people were affected. More than 15,000 villages were damaged or destroyed. The economic cost exceeded $4.5 billion in 1999 values. The sheer scale of the destruction, the completeness of it, the geographic spread of it, the way it erased not just structures, but entire communities, and the records that would have documented their existence, made the 1999 super cyclone a watershed moment in Indian disaster management. In its aftermath, Odisha undertook what has been described as the most dramatic transformation of cyclone preparedness capacity ever achieved by any state government in Asia. A network of cyclone shelters was constructed across the coastal zone. Early warning systems were modernized and expanded. Evacuation protocols were developed, rehearsed, and refined over the following 2 decades. Those systems were tested in May 2019 when extremely severe cyclonic storm Fani, a storm whose intensity at landfall was comparable to the 1999 super cyclone, struck the Odisha coast near Puri, again within close range of Bhubaneswar. The storm made landfall as one of the strongest cyclones ever to strike India, with winds of 250 kilometers per hour and a significant storm surge. This time, however, approximately 1.2 million people had been evacuated from the coastal zone in the 48 hours before landfall, the largest cyclone evacuation in Indian history. When Fani's winds subsided, the death toll stood at 89. The infrastructure damage was catastrophic, estimated at $8.1 billion. And Bhubaneswar itself was severely impacted, losing nearly every tree in the city and sustaining major damage to buildings, power infrastructure, and water systems. But 89 people died, where 20 years earlier, under similar atmospheric conditions, more than 15,000 had perished. That comparison, 15,000 deaths in 1999 versus 89 in 2019 under meteorologically comparable conditions, is, in the language of disaster science, almost miraculous. Meteorologists and emergency management specialists who have studied the Odisha transformation describe it as proof that human systems can learn, adapt, and change the relationship between atmospheric violence and human mortality. But they also note what did not change: the atmosphere itself. The Bay of Bengal continues to warm. The cyclones it generates continue to intensify. The frequency of rapid intensification events in the bay has increased measurably over the past 2 decades. Climate projections for the remainder of this century indicate that the Odisha coast will face cyclones of greater intensity, higher storm surges driven by rising baseline sea levels, and potentially shorter intervals between major events. The window of preparation time that currently exists between storm formation and landfall, the window that made the Fani evacuation possible, may narrow as storms intensify more rapidly and travel more erratically. Bhubaneswar sits 60 kilometers inland from the coast at an elevation of approximately 45 meters, which provides some buffer against direct storm surge. But the city's infrastructure, its power grid, its water systems, its roads, connects directly to the coastal zone that Fani demonstrated can be devastated in a single afternoon. Approximately 1 million people live in the city itself. The surrounding Odisha coastal plain, where the atmospheric violence is most concentrated and most direct, is home to tens of millions more. What makes the Odisha coast and Bhubaneswar the #1 entry on this countdown is not simply the historical death toll, nor the frequency of major cyclone strikes, nor even the documented intensity of the events it has endured. It is the combination of all of these factors converging in a single geographic location, the most cyclone-exposed significant coastline on Earth, home to one of the largest concentrations of vulnerable human population, facing an atmospheric future that every available scientific model suggests will be more violent than its already extraordinary past. Meteorologists who have studied the Bay of Bengal describe Odisha's atmospheric situation with a specific kind of professional gravity, not the detached technical language of risk assessment, but the weight of people who understand both the science and the human reality, and who know that the gap between those two things, between what the atmosphere is capable of and what human systems can endure, is the space in which history is made and lost. No other location on this countdown makes the case for that truth with more evidence, more history, or more urgency. There is something that every city on this countdown shares, something that stands apart from wind speeds and storm surges and death tolls and economic damages. It is this: people live there. They have always lived there. After every storm that was supposed to end it all, after every event that the rest of the world watched in stunned disbelief, people came back, rebuilt, remembered, and chose to remain. That decision is not ignorance. For most of the communities on this list, leaving is not a simple calculation. Home is not simply a location on a map. It is generations of family, livelihood, culture, identity, and belonging, all rooted in a specific place that happens to lie in the path of something vast and indifferent and extraordinarily powerful. The meteorologists who study these cities do not only see victims, they see people who have developed knowledge about weather, resilience, and survival that is thousands of years deep. Knowledge that cannot be duplicated in laboratories or computer models. The storms, though, are changing. The atmosphere is warming. The systems that these communities have learned to survive are becoming more intense, more rapid in their development, and less predictable in their behavior. The next chapter of every city on this list is still being written by the atmosphere and by the people who refuse to leave. Which city on this countdown shocked you the most? Let us know in the comments below. And if this documentary gave you a new understanding of what people around the world endure in their relationship with the sky above them, please consider leaving a like. It helps more people find this content. Subscribe and turn on notifications so you never miss a new documentary. The next one is already in production, and what it reveals about the world's most extreme places may be even harder to believe than what you just watched.